Today we are doing the second half of transformation of functions. Okay, we are going the other way, basically going from the graph to the equation. You can close computers now. We're writing the equation from the graph. Okay, to remind you from Friday, if we have a graph like f of x equals a would be this point right here, okay? Identity is the one that cuts quadrants 1 and 3 in half. Remember, you should have arrows on the end. Arrows on the end here. Arrows on the end here. Absolute value graph looks like this. Absolute value is always in the shape of what? A V. Okay? So absolute value is always in the shape of a V, and a quadratic is in the shape of a U. If we're looking at this identity function right here, y equals x, Shay, be quiet, please. If we're looking at this identity function, what would the domain and range be? All reals, both, okay? Just to remind you, interval notation would look like this. Negative infinity to positive infinity for both domain and range. Okay? Just to remind you. When's your test? Thursday. Okay? Coming up. The review and the review solutions are posted. Thank you, sir. Andy. Can you grab that right there? The review and solutions are posted. You can start working on it. We will work on it during class tomorrow, all day. Okay, that's all we're doing is a review. What up? Did you see my...
That's my kid.
Yeah.
Hold on 1 second.
Hold on.
Man.
It's all good.
I didn't check fast enough. And then
The kid came back like 5 minutes later, so it was all good. But frequent...
They being good?
It's that back table group.
Yeah.
Is this what?
Right there. I gave you.
There, virtual. Virtual fist bump. That's all he's got, man. Here, look. We'll do it and it transfers to you. Can't get away. Okay. So, remember this equation, right, Leah? Chatterbox? Aww. It's never the kid's fault. It's so funny. So we have this equation A times the quantity x minus h plus k. I don't like how that's written, but that's okay. So general form is that each constant in the equation, and we'll talk about what that means as we go along. So if we had a number like 2x minus 3 squared plus 4, the constants would be 2, 3, and 4. Okay? In this general equation, h comma k is the vertex. Absolute value of A either stretches or stretches or compresses the graph. When A is negative, the graph reflects across the x-axis. The value of h shifts the graph left or right. We went over all this on Friday, right? Just reminding you. The value of k shifts the graph up or down. I'll let you get caught up. So, if we're looking at this first graph right here, what's the parent function? Absolute value of x or x squared? X squared. What's the parent function of this one? Absolute value of x. You got to be able to tell those apart, right? Absolute values in the shape of a v, like this. If it's x squared, it's in the shape of a u. Okay? So where did this graph move, the first graph right here? Up 4, right? So that's what we say when you describe the transformation. It went up 4. So the equation, because it's x squared, is x squared plus 4. You could put y equals in front. You could also put f of x equals in front. Doesn't matter. Either one I'm fine with. Where did the second graph move?
Down 5.
Down 5, right? That's how we describe it. Down 5. Easy peasy, right? And then that equation would be y equals absolute value of x minus 5. So those are the vertical translations up and down. It's always after the function, right? The changes come after the function. When it goes left and right, then it's inside with the x squared. We have like parentheses minus or plus 4. This one, I wish they just didn't put this one on here. So we think about the parent function being like this. It's y equals x. And then it moved up 1, 2, 3. The problem is you can also make the case that it moved left 3. And it's the same dang thing. Okay? We're just going to write it like this to keep it simple. So x is a parent function. We're going to say up 3. The equation is y equals x plus 3. If we graph that line, it would look like the equation here, right? So that's why it's plus 3 instead of the minus 3 within the parentheses. It just gets too weird that way. Well, I taught Algebra 1 last year, and the way they explained this to the Algebra 1 kids was a nightmare. Like, it just, nobody was going to understand it. And it's not that important. It's more important to be able to look at the vertex and tell what happened. Right, parent function goes like this. So where did this one move? Left 6. So that equation would be y equals, I'm leaving the sign out for now. Is it plus or minus?
No, it went minus because it's going left.
Right, so the equation here, I want you to see what the equation is because I think it
Oh,
helps.
no, it's in parentheses, so that's why it's plus.
Yeah, that's why it's opposite sign, right? When it's in the parentheses, it's opposite sign. So if you write this, I think this helps you because we'll be talking about this all year. And if you can get this down now, it's just going to help you so much. So I always think of what's in the parentheses as opposite sign. Organized use of color is your friend. Remember, I check your notes during the test. And I want to see color. So let's say you're a kid who forgot to use color for the entire module. You can buy a highlighter and highlight some stuff that's important, right? It'll help you study for the test. So same thing works with absolute value, right? Because I could just change these parentheses to absolute value without the squared. It's still opposite sign, same sign, okay? Doesn't matter what the function is. The transformations kind of stay the same. Okay, where'd this v move? Parent function, absolute value of x, it moved to the right 3. So it would be y equals absolute value of x plus or minus 3. What does it say? Plus or minus 3? He's so scared. He doesn't know. You didn't know, right? It's okay. It happens. Minus. Because it's opposite of what you think when it's in the bars. Right? Because it goes plus, it's actually minus. Oh, really? You had it right on your paper. That's always annoying. That happens. So here we have x squared. What happened to the function? What happened to the function? Reflect across x-axis. Excellent. I'm just going to say reflect x-axis to save time.
Why do you have to put, for the previous one, why do you have to put x as the value of x minus 3?
So question is, why do I have to put absolute value of x minus 3?
Why do you have to make it minus 3 and not plus 3?
The h part is 3. So if I were to do the vertex of this function, it's right here, right? The vertex would be what? 3 comma 0. Remember in the equation up here that in the parenthesis it's always opposite sign.
Yeah.
So this was a plus 3 right here, but it's opposite sign.
But it's an absolute value, so anyway, it would end up as 3.
Can't think of it like that.
No?
You just got to think about it. It's a valid point. I totally get it. You got to think about it like this with the h and the k. And anytime it's in the parentheses with the squared or in absolute value bars without the squared, this is always the opposite sign. Totally valid question. It's good. So here's the equation, right? Negative x squared. That's all that one is. Vertex didn't move anywhere, right? Both h and k are 0. That's why there's nothing else there, okay? So first thing I like to do after identifying the parent function, we'll do it on both these. X squared, and the second one's absolute value, right? Because it looks like a v. Where is this vertex right here? 4 comma 2. So 4 is the h, 2 is the k. If we think about our equation, I'm going to write the equation with absolute value bars over here, just so you can see how similar they are. Right, again, it's always opposite sign in the bars or in the parentheses. Same sign always outside of the parentheses. So it moves 4, 2. Try to write the equation. I'm going to freeze my screen. See if you can write them both. See if you can write them both. Tell me what the transformations are, and then we'll talk about it. It's good. I like to hear the conversations in the table groups about math. Some of the table groups are talking about math, not all of them, but I like to hear those conversations about math. You guys want to see? How many people are done? You wrote both equations. If your hand's not up, you're just not trying. That's all I got to say, right? So, are you lying, Ryder? I know you're lying. I can see it in your eyes, man. I know, but did you write the equations down here is what I'm talking about. Mm-mm. Raise your hand if you got them both right. Nice. You think you might see one of these on the test?
Yeah.
You might.
But like, I'm confused because isn't that because it's the opposite? Isn't that supposed to be plus or because it's still no? Because
The 4 is positive, so in the parentheses
yeah,
it's got to be
that
negative.
Would be positive because that's in the negative.
That's -1. If we rate the vertex, -1, -3, right? So h is -1, k is, so the reason it's minus, the equation would be like this.
Or like it's not supposed to be there because they're both negative numbers.
This equation is not totally simplified, right? Because the minus minus, that's what makes it a plus. Because there's a minus in the formula right here. And if it's already minus 1, there's a minus from the formula. There's a minus from the ordered pair. That's the minus minus makes plus idea of the thing. Burrell, question.
In the top left, you have the equation. What is the A?
A tells you like if the graph is stretched skinny, right? Or if it's wider. So the A makes it either, it could be upside down as well, right?
Why is it in the answer, like below us, the y equals 1 times x minus 2?
This thing,
No, the one to the left.
this one.
Yeah, why is it in that equation? The
A would be 1. So it doesn't matter, right?
A. Okay. In a test, should I write down A or 1 for the answer?
You don't have to write A unless there's a reason to write A, which is a beautiful segue into the next problem, okay? Because it changes. So right here, H and K. Leah, what's H and K on that equation?
H is
She's going to try to pull it out.
H is 0.
Good? Good. Way to pull it out. Good job. Okay, parent function, absolute value of x. So what happened here? The equation went,
Reflection of the y-axis. Right?
what is that slope right there? It went up how many? Went up 1, and it went,
Over 2.
so is that positive or negative, that over 2? Plus 2. So if we think about A is really 1 over 2.
Is there problems when it says that it's like reflecting over the y-axis or it's just the x-axis?
Just x-axis for now. So the only thing that happened is this is a vertical what? Stretch or compression? Compression because it's smushed, right? Smushed down. It's like me putting my hands on your shoulders and like smushing you into the ground, right? It's a vertical compression. Because A is also less than 1, that makes it a compression. If A is greater than 1, it makes it a stretch. You have to always have to say by whatever it is. In this case, it's 1/2. Because we can count from the vertex, go up 1 to the right 2. That's why they're both positive. So the equation is then y equals 1/2 absolute value of x. You finish that homework? See how I pay attention? Isn't it kind of annoying, right? Okay, what's the vertex right here, Elise? What's the vertex right here, Elise? 2, 0. Good job. Way to pull it out. 2, 0. So if I count out my slope on this equation, right, I go down how many? So you could say -3, right? Because technically I went down 3. There's no question, right? And I went to the right or left 1? Right 1. So because it's upside down, right? Parent function, forgot to write absolute value of x. So this one also, the vertex is 2, 0. So the 2 is my h, the k is 0. So is that minus or plus 2 in the parenthesis? Or in the absolute value bars? Minus. Plus 0, you don't have to write. What goes in front of the absolute value bars?
Yeah, it's
-3, right? Because it's upside down. So you can think of that negative as separate because that's really a reflection over the x-axis. And the 3 is what stretches it so it makes it skinnier, right? So we have three transformations here. First one, reflect x. Second one is the 3, so that's a vertical, I'm abbreviating vertical stretch VS by 3. And then last is right 2. Okay? All right, just a few more things and we're done. Most kids finish their homework, okay? You're good. I generally go a little fast, so you can slow me down. It's totally fine. Okay. Look how much down your grades are going to go. All right, I glance back there, then I double check cell phones, and you all lose 5% of your overall grade. That's so sad. So sad.
You like mean on the test, right?
No, I mean overall. Your entire grade is 5% lower. So, if absolute value graph is vertically stretched or compressed, the value of absolute value of A tells you the slope, rise over run. So that's what we're talking about here, that slope, rise over run. I'll take your question in a minute. Rise over run. Right, first thing you do when you walk in this class is put your phone up. You all, none of you did. When I'm done with the notes, you can all go put your phones up so you can focus on the homework. Okay? So rise over run is where I was at. I would highlight some of this stuff because it's important. So vertically stretched, vertically compressed, absolute value of A tells you the slope or rise over run for each side of the graph. This will make the graph appear skinnier if it's vertically stretched or wider if it's vertically compressed. Okay? All that stuff, we've now said this stuff like 4 different times over the last 2 days of notes in this class. So if you still don't have it down, you got to make some flashcards, right? If I give you this equation, my expectation at this point is you could just graph that, right? You'd be able to get a graph paper and be able to graph it, no problem, okay? So if you're not there yet, homework is practice, right? So that's part of it, right? But to practice for a test, doing the review itself is not enough. I had a kid asking after 6th period, like, what should I do to study? He already did the review, right? And I said, what I did when I was in high school, I'd always do the review, of course, right? But I would then go back and look at the homeworks, look at medium difficult problems, because I didn't need to do the easy ones. I generally understood those. And I would go to the medium difficulty and practice those. And I might try a hard one or two in each section and just see where I'm at, right? I didn't get 95s or 100s on every math test in high school, but if I did that preparation, did the review and went back and looked at homework, practicing medium and a couple of difficult problems, then I would usually get an A on the test. If I did something less, I would usually get a B or a C on a test, right? I was no like genius or anything, but I knew how to study and I knew how to work hard. So when I wanted it, I could get an A pretty much always, right? That's not the case for everybody. It's okay, right? As long as you're working hard, that's all I care about. All right. You had a question.
Yeah, I was going to say, I put my phone in there, but I didn't put it in, like, I'm not sure if I put it in the slot
That was yours. And I'm not sure where I put the phone slot numbers. I think I brought them home because I was going to make the list and put it up there, but you're good. Thank you. Okay, so last problem, real world application. Suppose the path of a dolphin during a jump is modeled by the equation g of x. Elise. G of x equals negative 0.125 times the quantity, that's how you read parentheses in math speak, times the quantity x minus 12 squared plus 18, where x is the horizontal distance traveled by the dolphin. Technically h is a horizontal distance. And I see what they're saying. G of x is the height above the surface of the water. So what's A in this equation? It should really be 0.25, not negative. So the negative part of that just turns the parabola upside down. Has anybody seen a dolphin jump out of the ocean? Right? It's pretty cool, right? Like amazing. I was walking along the beach when my son was so little. He's now like 25. He was little, like in the baby Bjorn thing, the little baby carrier thing. We're walking along the beach, and there was like a, what do they call them? A school of dolphin? Is that what they are? School of dolphin was just like jumping along the beach as we were walking down the beach. Super cool. So if you have your graphing calculator, get it out. I want to show you one thing, which I've shown you before. So put in 0.125, math, enter, enter. 0.125, math, enter, enter. Homework's on the calendar, so you can just get it up there. So 0.125, math, enter, enter, and you should get 1/8. Just so you know, so that 1/8 is like that slope, right? So it'll go up 1 feet, to the right 8 feet. At least, please be quiet. Up 1 foot, to the right 8. Okay, does that seem like what a dolphin would do? Up 1, right 8? Makes sense to me. So 12 feet, right? So that minus 12 means, is the dolphin jumping backwards or forwards? Forward, because it's opposite sign, right? Because the minus 12, it's really going 12 feet, so it jumps out of the water, and it goes 12 feet all the way over here. Right, so 12 feet seems maybe reasonable. What number doesn't seem reasonable is that positive 18. Have you ever seen a dolphin jump 18 feet in the air? They probably could. Like if you see a SeaWorld show, they teach them how to jump super high. But if the ground where the ocean, where the water level is, that means behind Maya's head, you'd be able to see the dolphin like jump through the window. That would be like the Michael Jordan of dolphins, right? It would be able to jump super high. So I think the 18 is a bit of BS. The negative is what turns it upside down, right? So the parabola is like a dolphin would jump out of the water, right? So a couple things. What's h in this equation? So we're looking at the equation here. It's 12. And the k is 18. That's where I call BS on this problem. Like I don't think a dolphin jumps 18 feet in the air, right? Unless it's trained at SeaWorld. So we want to address each number you stated. And I'm going to say, like, because this is the absolute value of A, right? And the negative is what makes it upside down. So what does the negative do? Reflect x. So I'm just going to put it in parentheses and write reflect x-axis. So the 12, if I think about the dolphin jumping, right, like this, the top of that vertex is the 12, 18. How far did the dolphin jump from here to here? 24, right? Because this distance from here to here is 12. So that's where the vertex is. And then from here to here is another 12. So it jumped 24 feet. That's like from that wall over to the windows. That's really far, right? So maybe if a shark were chasing the dolphin and need to get the heck out of there quick, it might jump 18 feet in the air and then 24 feet. But that's like really far for a dolphin to jump. At least the dolphins I saw. They were just kind of chilling, like jumping up and down in the water, having a good time kind of thing. They weren't fending for their lives. So the 0.125 is the slope, right? How many up, how many to the right? So the 0.125, I'm going to write or 1/8, right? Just because we get that. Because going up 0.1 and right, that's just confusing. Or 1/8. It's like the slope of the function. Slope of function. And we're answering the questions below by doing this. So we're basically done after we do this. Slope of function. And then the 12 is the distance from where it left the water to the height of the jump, right? So the 12 is starting to the highest point of the jump. So I'm going to say start to highest point. And then the 18 is how high the dolphin jumped. At the peak, it was 18 feet. And then for these questions down here, I'm just going to say, see above, because we already answered all those questions. Yes?
What's the difference between 12 and 18?
So 12 is the distance from where it left the water right here, right, to the middle. And 18 is the vertical distance, right? If you think about X and Y, right, Y is up and down, and X is left and right. So the whole distance is 24, half that distance is 12, and then the height would be
Goes from
18. So not drawn to scale, that picture, right, because it's too far smushed down. Yeah. There is your homework. Get her done. I'll come around and check.